What also is a heavy one is what caused the Big Bang?
Yeah.
Like, why would something smaller than the head of a pin become everything that we see in the cosmos?
Yeah. So there are ideas for the answer to that question. Look, all of this is tentative because it's very hard to do measurements that go all the way back to the beginning. We have astronomical observations that we need to be sure are compatible with the predictions of our theories and so forth. So we as good scientists do what needs to be done to try to test these ideas. But the idea that I think most physicists or cosmologists buy into at the moment is that gravity can have two manifestations. The usual form of gravity that you and I know about is the attractive version. You drop something toward the Earth and it moves downward because the Earth and the object pull on each other. That's the ordinary gravity that we experience every day of our lives. But Einstein's equations actually allow gravity to also be repulsive. It can push outward as opposed to just pulling inward. And this is something that we have never experienced because the gravity created by a rocky object like the Earth is always the attractive variety. The gravity created by the sun, again, a compact object, is always the attractive variety. But Einstein's math shows that if you don't have a rocky object that's isolated in space, but rather energy that is uniformly spread through a region of space, that kind of entity yields repulsive gravity. Why is that important to your question? If the very early universe, that little tiny head of a pin that you're talking about, if it was filled with a uniform bath of this energy, we call it the inflaton field, the name doesn't matter, but if it was filled with that energy, it would have been subject to repulsive gravity. What does repulsive gravity do? Pushes everything apart, causes everything to rush outward. So the bang of the Big Bang may have been a spark of repulsive gravity operating with a tiny region of space that pushed everything apart.
And this concept of repulsive gravity is just theoretical? Have we observed any sort of element in the universe that...
It is theoretical, but it's at a level of understanding that I think most physicists would say causes it to migrate into the camp of established understanding of how gravity works. So number one, Einstein's equations have now been tested over and over again in a whole variety of circumstances. The detection of gravitational waves just a couple of years ago is like the crowning triumph of Einstein's math. 100 years ago, the math says there should be ripples in the fabric of space. 100 years later, we finally detect ripples in the fabric of space. So we are very comfortable with any prediction that comes out of Einstein's mathematics.